Next is the division of surds. You have 6 root 2 over 3. 6 is a whole number, then you have 2 under root or under square root over 3. If you are asked to divide this, you go with the whole numbers, that's 3 and 6. You can't touch the 2 because it's under root. You have 3 in 3, 1, 3 in 6, or 6 divided by 3, that's 2. You're left with 2 root 2. So your answer is 2 root 2. This is over 1, the 1 can go away. Any number divided by 1 is that number, so you have it as 2 root 2. That's first question. Second question, you have 3 root 2 over 6. You go with the whole numbers, 3 in 3, 1, 3 in 6, that's 2. These 2 can go in these 2, but this 2 is under square root, so you can't touch it. They can't work, so your answer is equals to root 2 over 2. The answer to the second question is root 2 over 2. Then to the third question, we have 3 root 2 over 6 root 2. 3 and 6 are whole numbers, and these 2 are in roots. Since they are the same, you can say root 2 cancels root 2, 3 here 1, 3 in 6, 2. Your answer is 1 over 2. You have 1 left at the top or at the numerator, then 2 at the bottom or at the denominator. Your answer is therefore 1 over 2. Question 4. What if you have 4 root 2 over 6 root 3? This root 2 and root 3 can cancel, they don't have anything in common. But you can work with this 4 and the 6. 2 can go in 4, that's 2. 2 in 6, that's 3. Your answer will be 2 root 2 over 3 root 3. That's just division. We're not going to rationalizing the surds. At this point, let's just leave our answer like this. 2 root 2 over 3 root 3. Question 5. What if you have root 6 over root 2? This root 6 can be broken into 2 times 3 under the square root over root 2. And once they are linked by times, you can give them their separate square root at the numerator. You have square root of 2 times square root of 3 over square root of 2. Root 2 cancels root 2, or square root of 2 cancels square root of 2. You'll be left with root 3 as your final answer. And rather than go through this process, let's say you have an OBJ question, you have root 6 over root 2. Both of them are under the same root, so you can say 2 in 2, 1, 2 in 6, that's 3. We have it as root 3 over root 1. This 2 is left with 1, so you have root 1 at the denominator. We can further say root 3 over, root 1, square root of 1 is 1. So anything over 1 is that number. Root 3 divided by 1, anything divided by 1 is that same thing. Therefore, root 3 divided by 1 is root 3. And for a quick one, you've done 2 in 2, 1, 2 in 6, that's 3. So you have root 3 over root 1. Root 1 is 1. You just know your answer is just simply root 3. You can skip these 2 steps when you have root 1. You just need to know that root 1 will go away, and your final answer is just root 3. The roots don't cancel out. You just work on the numbers under the roots, provided they are having the same roots. If one were to be in root 2 or square root and the other was to be in cube root, you can't cancel. Question 6. Let's say we have root 6 or square root of 6 over square root of 8. You can just save time and say what can go in 6 and 8? 2 can go in both of them. You have 2 here, 3, 2 here, 4. You have your answer as square root of 3 over square root of 4. This is not your final answer. The square root of 4 is 2, so you have square root of 3 over 2, because square root of 4 is 2. This is your final answer. And if you want to do it the proper way, you have root 6 over root 8. And since they have 2 in common, you make their products have 2 in it. So you have 6 as 2 times 3, that will give you 6, and 8 as 2 times 4, that will give you 8. Next, you give them their separate square roots at both the numerator and the denominator, that's on top and below. So you have root 2 times root 3 over root 2 times root 4. Root 2 cancels root 2. You have root 3 over root 4 left. Root 3 over root 4 is square root of 4, that's 2. Your answer is still same as the first way of doing it, and I think this way is easier, but you have to be careful using it, and most likely avoid using it in theory. Question 7. What if you have 2 root 2 times 4 root 3 over 2 root 3? Since they are linked by times, you can cancel at any level. It's like having 2 times 3 over 3. 3 can cancel 3, you'll be left with 2. Same applies to this. This 2 whole number can cancel this 2 whole number, and this root 3 can cancel this root 3. You're left with root 2 times 4. Root 2 and 4 left. Root 2 times 4 is 4 root 2. You put the whole number before the number in root. Question 8. What if you have 2 root 2 plus 4 root 3 over 2? Now this works like you have 2 plus 4 over 2. You can't just say 2 into 1, 2 into 1, 1 plus 4, that's 5. It's wrong. In this case, you have 2 plus 4 over 2. 2 plus 4 is 6 over 2. 6 over 2 will give you 3. You see, you get a different answer when you add them before dividing than dividing when they have addition, and same applies to subtraction. You can't do this. The only way you can do this and get the same answer as this is if you have 2 plus 4 over 2. When it's addition or subtraction, the 2 affects both of them. It's like saying you have 2 over 2 plus 4 over 2 separately. 2 into 1, 2 in 4, that's 2. 2 plus 1, 3. At this point, you get the same answer as this, which is the proper way of doing it. Or you can take the 2, leaving them like this. 2 here, 1, 2 here, 1. That same 2, you have to work on this 4 too. 2 in 4, that's 2. You'll be left with 1 plus 2, which is also 3. And this applies to working with surds too. You can't just say 2 into 1, 2 into 1. The 2 affects both this 2 and this 4. So you can choose to separate them or factorize before you divide by 2. So in this case, let's factorize. We have 2 into root 2 and 2 in 4 root 3. That means you can find 2 here and you can find 2 here. That's 2 times 2. You take out the 2. After taking out this 2, you have to divide this 2 root 2 by the 2 you took out. So 2 root 2 divided by 2, the 2 will cancel out. You'll be left with root 2. So you have root 2 here plus behind we have 4 root 3 divided by 2. 4 root 3 divided by 2, 2 into 1, 2 in 4, 2. You'll be left with 2 root 3. So you have this as 2 root 3 in close bracket over 2. If you multiply this 2 by this root 2 and by this 2 root 3, you still get back 2 root 2 plus 4 root 3. That means we're doing the right thing. And at this point, this 2 is linked to surds in the bracket by times. So this 2 can now cancel this 2. You'll be left with root 2 plus 2 root 3 as your final answer. You can also take question 8 from this angle where you have 2 root 2 plus 4 root 3 over 2. This 2 will cancel this 2, 1, you'll be left with 1 here. And this same 2, since they are linked by addition, and even if they are linked by subtraction, you still do the same thing. These 2 will also have to work on this 4. That's 2 in 4, that's 2. You'll be left with 1 root 2, which is also root 2, plus 2 root 3. That's the answer. It's the same answer using 2 different techniques. Question 9, you have 2 root 2 plus 4 root 3 over 2 root 2. You can't just cancel out, or you can do the shortcut method where the 2 will have to go in both this 2 and this 4. Or you factorize. You have both 2 in 2 and in 4. So you take out 2. Here, if you take out this 2 from this, you'll be left with root 2 plus, if you take out 2 from this 4, you'll be left with 2. That's 4 divided by 2, that's 2 root 3, close bracket, over 2 root 2. This 2 cancels this 2 at this point. This is linked to this by times, and this is linked to this by times, so you can cancel out. What is left in the bracket is root 2 plus 2 root 3 over root 2. This is your answer at this point, except you are rationalizing, where you don't want a surd at the denominator level. And that's part of this surd series. Question 10, you have 2 root 2 plus 4 root 3 over 4 root 2 plus 6 root 3. To factorize this, there's 2 here and there's 2 here. You bring out the 2 that is common, you'll be left with root 2 here when you take out this 2, plus from this 4 you take 2, you divide by 2, you'll be left with 2 root 3 in bracket over. You can also take 2 from both of them. There's 2 in 4 and there's 2 in 6 as the highest common factor, that's HCF. You take out 2, you'll be left with 2 root 2. Then from this you take out 2, you'll be left with 3 root 3, close bracket. At this point we can say this 2 will cancel this 2. Nothing can cancel here. Let's just write what is left first. You have root 2 plus 2 root 3 over 2 root 2 plus 3 root 3. At this point, you can't just cancel out because they are linked by addition. Root 2 plus 2 root 3 over 2 root 2 plus 3 root 3. Answer. Question 11. Root 2 minus root 3 over root 2 minus root 3. Taking a look at this, the root 2's are in front, the root 3's are behind. They both have negatives. If they are the same, exactly the same, you can cancel out. You can say this cancels this. Your answer is 1. It's like saying 2 over 2. 2 over 2 is 1. 3 over 3 is 1, and so on. So if they are exactly the same, you can cancel them out and their result is 1. Question 12 looks similar, but it's quite different. You have root 2 minus root 3 over root 3 minus root 2. They are not the same. Here the root 2 has a positive, the root 3 has a negative. Here the root 3 has the positive and the root 2 has a negative. You can rearrange. We can say root 2 over root 3 over, we'll take the root 2 with the negative it owns, minus root 2 plus root 3. No, this root 3 has a positive in front of it. If it's empty, it has a positive in front of it. So we rearrange it, root 2, root 2, root 3, root 3. We can still do something to this. From the denominator, we can bring out minus 1. You know this root 2 has a 1 in front of it, and this root 3 has a 1 in front of it. And at this point, we can bring out minus 1. The minus 1 changes the sign of this root 2 and of also this root 3. So we have it as root 2 minus root 3 over minus 1. You bring out minus 1. The minus 1 doesn't change the numeric value, but just changes the sign. So you have root 2 or plus root 2. The minus turns to addition. Then this plus root 3 loses its positive. Then the positive of this root 3 turns to negative. So you have minus root 3. If you choose to multiply minus 1 by plus root 2 and minus root 3, you get this value back, which is minus root 2 plus root 3. So you brought out minus 1 to make them the same. Here you have plus root 2. Below 2 you have plus root 2. You have minus root 3. You have minus root 3 behind. Since the minus 1 is linked to the surds at the denominator by times, and since this is same as this, you can cancel or you can cut. Plus root 2 minus root 3, we cancel plus root 2 minus root 3. You'll be left with 1 over minus 1. This one has a positive. Positive divided by negative is negative. Then 1 divided by 1 is 1. So our final answer is minus 1. The 13th question. We have 2 root 2 minus 2 root 3 over 3 root 2 minus 3 root 3. If you have this kind of question, at the numerator you have 2 common, at the denominator you have 3 common. You bring out what is common, you factorize at both the numerator and the denominator. 2 is common here, you bring out 2, you'll be left with 2 divided by 2 root 2. The 2 will take the 2, leaving the root 2 behind. You'll be left with root 2 minus this same 2 in 2 root 3. Let's just write it out. 2 root 3 divided by 2. The 2 will cancel the 2, leaving root 3 behind. We'll have your root 3 here in brackets. Over. At the denominator, we have 3 in common. We bring out 3. You open our brackets. If you take out this 3 from this 3 root 2, let's say this 3 goes off. You'll be left with root 2 minus. The 3, you take it out in this 3 root 3. The 3 will take this 3 off. You'll be left with root 3. You have root 3 behind. You close your bracket. At this point, we see that the surds in bracket are the same at the numerator and at the denominator. You have root 2 minus root 3, root 2 minus root 3 in bracket. At the numerator is linked to these 2 by times, at the denominator is linked to these 3 by times. Provided they are linked by multiplication, you can cancel out. This cancels this. You will now be left with 2 over 3, because this is 1 and this is 1. 2 times 1 is 2, 3 times 1 is 3. So you have your answer as 2 over 3. Question 14. We have 2 root 2 minus 2 root 3 over 3 root 3 minus 3 root 2. It's quite similar to question 13, but here we have your root 2 before your root 3 and there's a negative. When it's negative, it's dangerous. If it were positive, it's not really dangerous. You can switch them and still get the same value. But since it's negative, you have to be very careful with it. At the numerator, you have 2 common. You bring out 2, you'll be left with root 2 minus root 3. You take out 2 from this, you'll be left with root 2. You take out 2 from this, you'll be left with root 3. Similar to question 13. Over. What's common in the denominator? You have 3. You take out 3, you'll be left with, in brackets, root 3. Once you take out 3 from this 3 root 3, you'll be left with root 3. And you take out this 3 from this 3 root 2, you'll be left with minus root 2 in brackets. Now watch. The root 2 here is positive, but the root 2 here is negative. The root 3 here is positive, but the root 3 here is negative. You can't cancel out, but you can rearrange. You can have it as equals 2 into open bracket root 2 minus root 3 close bracket over 3. You know, here, at the numerator, the root 2 owns a positive. At the denominator, the root 2 owns a negative. At the numerator, the root 3 owns a negative. At the denominator, the root 3 owns a positive. We can still work with this. We can change the signs of the surds at the denominator. So we can bring out minus 1. You can take times minus 1. You open your bracket. Immediately you bring out minus 1, the root 3 now gets a negative. So you have minus root 3. Then the root 2 gets a positive plus root 2. You close your bracket. On the next line, you have equals 2 into bracket root 2 minus root 3, close bracket, over. You can multiply 3 times minus 1. 3 has a positive. Positive times negative is negative. Then 3 times 1 is 3. You open your bracket. You can rearrange this. You have minus root 3 plus root 2. Since you want it to look like the numerator, you can take the minus root 3 to the back and the plus root 2 to the front to make it exactly the same as that of the numerator. So we'll take the plus root 2 first. So you can write root 2 without the positive. Still means the same thing. And the minus root 3, you bring it behind minus root 3. Close your bracket. Once they are now the same, you have plus root 2 at the numerator, you have plus root 2 at the denominator, you have minus root 3 at the numerator, you have minus root 3 at the denominator. They can cancel out. This cancels this. We'll be left with 2 over minus 3. Our answer is 2 over minus 3, which is still the same thing as minus 2 over 3. Final answer. What if you have 2 root 2 plus 2 root 3 over 3 root 3 plus 3 root 2? You can choose to arrange it first to make sure the root 2's are in front, or you can factorize, then you rearrange. Let's just do it this second way. So you have 2 root 2 plus 2 root 3 over, we take this 3 root 2 first. 3 root 2, since it has a positive, you don't need to write plus 3 root 2. Leaving it empty is still the same thing as plus 3 root 2. So we take this plus 3 root 2 first. Then we have plus 3 root 3. If it's empty, it has a positive. So we have plus 3 root 3. Once we have it like this, we can factorize the numerator and the denominator. Since they have 2 in common at the numerator, we bring out 2. And they have 3 in common at the denominator, we bring out 3. We have equals, 2 is common at the numerator. If you take the 2 whole number from the 2 root 2, you'll be left with root 2. It's taking these 2 off, you'll be left with root 2. Since it's positive, you can have your positive here. Since you brought out 2, you take out this 2 whole number from this 2 root 3, you'll be left with root 3. Close your bracket, over. You have 3 common at the denominator, you bring out 3. Open your bracket. If you take 3 from this 3 root 2, you'll be left with root 2. Plus, if you take this 3 from this 3 root 3, you'll be left with root 3. You close your bracket. Once you have the surds in bracket at the numerator the same as that of the denominator, you can cancel out. You have root 2 plus root 3, root 2 plus root 3 in bracket, and the one at the numerator is linked to the 2 by multiplication, same as the one at the denominator. Provided they are linked in this case, like 2 is linked by multiplication to the surds, and 3 whole number is linked to the surds by multiplication also. They can cancel out. This cancels this. Your answer will be 2 over 3. That's our final answer. Question 16. You have root 2 minus root 3 times, in second bracket, root 2 plus root 3 over root 2 plus root 3 times, in second bracket, root 3 minus root 5. And you are asked to solve or simplify. Since you have root 2 plus root 3 at the denominator and root 2 plus root 3 at the numerator, and you have them linked with times here and here, this, since they are the same, can cancel out. You will be left with root 2 minus root 3 over root 3 minus root 5. Although you are not meant to leave your final answer in surds like this, we will still deal with rationalization of surds. But at this point, since we are just working on division, we can stop here. So we have our answer as root 2 minus root 3 over root 3 minus root 5. So we leave our answer at this point for now.